What I want to do in this video is to give you an alternate method for approaching a trigonometric substitution problem. If you have read the textbook, you may have noticed that occasionally you need to build a triangle that relates the x value and the theta value in order to substitute back in at the end of the problem. My preferred method for these problems is instead to build the triangle first. Suppose in your integral you have the square root of a squared minus x squared. Then you can build a right triangle with angle theta, and the goal is to make one of the sides of the triangle equal to this radical. If we make the hypotenuse a and the opposite side x, then the adjacent side, by the Pythagorean theorem, is a squared minus x squared. Then you can read directly off this triangle that sine of theta is x divided by a, which means that x equals a sine of theta. From here, you can figure out that dx is a cosine of theta d theta just by differentiating both sides. You can also relate this radical to the constant using cosine. So we know that cosine theta is equal to the square root of a squared minus x squared divided by a, or in other words, the square root of a squared minus x squared equals a cosine theta. Now you can use this information to substitute in for your integral. So you will replace the square root of a squared minus x squared in your integral by a cosine theta. Any x that appears in your integral, you'll replace with a sine theta, and you'll replace the dx by a cosine theta d theta. Similarly, if you have the radical x squared minus a squared appearing in your integrand, then you can build a right triangle with angle theta, where one of the sides has this length. We'll make x the hypotenuse, and we'll make a the adjacent side. Then the opposite side, using the Pythagorean theorem, will be the square root of x squared minus a squared. From here, you can read that secant of theta is equal to x divided by a, so x equals a times secant of theta. Lastly, you may have the square root of x squared plus a squared. In this case, we'll put the x on the opposite side, the a on the adjacent side, and this radical will give us the hypotenuse. So we can read off that tangent of theta is x divided by a, or in other words, x equals a tangent of theta. Now, one more time, I just want to point out that this idea of building the triangle is just helping you figure out which substitution should work. The book encourages you to memorize, okay, if you have this form in your integral, then you should use the substitution x equals a sine theta. And if you have this form, you should use x equals a secant theta, and this form tells you x equals a tangent theta. To me, it's a little bit difficult to memorize those because they seem rather arbitrary, so I find it a lot easier just to look at the triangles like I've shown you.